Configurable logic blocks, from now on called CLBs, are the main components of an FPGA. These elements are the ones that are going to be configured to implement our logic. These elements can be used to implement either combinational or sequential logic. A CLB can be seen as a prefab construction that can be customized according to the user needs. The same starting building block can be updated to meet new requirements. As an example, a block can be used as a single apartment, or it can be used just as a studio, or even a garage, or just as storage. We can use, or if you prefer, configure them as needed, but at the cost of losing a bit in performance. That, in the context of a prefab construction, can be seen as a comfort or room. But let's take into consideration the case in which more room will be needed. We can overcome the limitation imposed by the usage of a single block by combining together more of them, which is the same thing that can be done with CLBs. In Xilinx FPGA, a single CLB is a hierarchical structure composed of a set of slices that are, at the same time, composed of a set of lookup tables. The number of slices can be varied according to the device, but in general, a CLB contains a set of 2 slices, which is in the case for the Virtex-C, Virtex-5 or the 7 series, while 4 slices were present in the Virtex-2 Pro and Virtex-4 devices. A slice, in turn, contains 2 lookup tables and the necessary interconnect hardware. The lookup tables are elements that can be used to implement, in general, 4 input, 1 output functions. Newest FPGA, like the Xilinx 7 series, are composed by lookup tables that can be used to implement functions characterized by 6 inputs and 2 outputs. In the figure, we can see a 2-slice Virtex-C CLB. This CLB is composed by 2 slices, each of them containing 2 lookup tables. Therefore, at the end, the CLB is composed by 4 lookup tables. Lookup tables, or LUT, can implement an arbitrary logic function according to their configuration. At the end of the day, a lookup table in an FPGA is nothing more than a memory containing memory cells to implement a small logic function. Let us now see how a 4-bit lookup table can be used to implement a 4 inputs, 1 output function. A 4-bit lookup table is composed by 16 memory cells. In fact, 4 inputs bit can be used to address 2 to the power of 4 elements. Within this context, we can now use these 16 cells to store the 1-bit output corresponding to each specific input of the desired function, no matter its complexity. Given a generic logic function f of 4 binary inputs a, b, c, and d, a configuration of the inputs is therefore equal to a number going from 0 to 15. This is done because, as we know, 4 binary inputs can generate 2 to the power of 4 possible input combinations of unique numbers. The memory cells need to be just 1 bit wide, and the bit stored into them is going to be nothing more than the output of the truth table that is used to define the logic function that has to be implemented. Do not worry, we are going to see more on this with some examples. Within this context, configuring a lookup table means to properly store the necessary sequence of zeros and ones in the 16 memory cells, according to the desired function. Each line is then connected to a multiplexer which is used to read the output of the function we are looking for, by connecting the desired memory cell via the proper configuration of the multiplexer, set by reading the A, B, C, D inputs to the output signal of the lookup table. Around the lookup table there is the interconnect logic that routes signals to and from the lookup table, implemented using standard logic gates, multiplexer, and latches. Therefore, during the configuration process of an FPGA, the memory inside the lookup table is written to implement a required function, and the logic around it is configured to route the signals correctly in order to build a more complex system around the basic building block. The input-output blocks, or IOBs, have the function of interconnecting the signals of the internal logic to an output pin of the FPGA package. There is one and only one IOB for every IO pin of the chip package. The IOBs have their own configuration memory storing the voltage standards to which the pin must comply and configuring the direction of the communication on it, making it possible to establish monodirectional links in either way or also bidirectional ones. The input-output blocks can be seen as a standard input-output interfaces that we may be already used and familiar with, as a microphone input jack or an audio output one. Now, one other thing which is quite interesting to be noticed is that the I/O pin will be physically bound with external component by the board vendor. Therefore, whenever you are going to be interested in using a certain board instead of another one, please be careful in checking the connectivities before implementing your design. Finally, the interconnection resources within an FPGA allow the arbitrary connection of CLB and IOBs. The main modes of interconnection are direct and segmented. We are going to see more on the interconnection in the following lecture, because they deserve some time to be properly described.